and thank you for having me here today. As Jack said, I'm presenting on behalf of our master's student, Stephanie Stiley. And she only got back from the field maybe a month ago, and she only finished tidying up the data set to give to me 2 days ago. So apologies, it is very, very preliminary, and hopefully next year we'll have a lot more detail to tell you about. As I begin, I'd like to acknowledge the traditional owners of the land where I live, the Wurundjeri, and the lands where this took place, the Gadigal. It's an amazing place. It's a long way from my home country now. And yet this team here, as Lizzie said at the beginning today, is so powerful and has so much potential that we keep coming back because we can't keep ourselves away. I'd also like to thank, of course, Steph's other supervisors, Julian, DiStefano and Jack, and Mark and Jess and Tamika, all the many, many people who have helped Steph with this fieldwork. It's been a lot of boots on the ground effort. And it's been very generously supported by Parks Victoria through their Applied Park Management Research Scholarship and their ARC Research Council, in collaboration with the CEC and Parks Victoria and DECA, a team of many people. So it's not news to anyone here today, I don't think, that Australia has an absolutely appalling record of native mammal loss. Species like the desert bettong, the burrowing bettong, the broad-faced potoroos are gone forever. But we have species that look not dissimilar to those that are still here. This long-nosed potoroo is a special animal. It's still persisting in parts of this landscape, and we have an immense responsibility to make sure that it continues to stay here. So why does it maybe differ from the species that we've lost? Well, it's not immediately obvious. It is vulnerable. It weighs between 600 grams and a bit over a kilogram, which makes it ideal kind of prey for things like foxes. It's not highly fecund. The females will have one offspring at a time, maybe a second one if the breeding season's long. And they use a range of habitats. So they like denser vegetation. They'll also go and forage in open parts. And they're subject to threats, including predation by foxes and feral cats and altered fire regimes. So there's places where these potoroos are still hanging on. And one of them is the Carlisle Heath, which has been a bit of a feature of today. And it's in this habitat in the presence of foxes and cats. There's no current fox baiting in the Carlisle Heath, and this species has been there in the presence of these introduced predators for well over 100 years. And it's incredible. I had another master's student try and trap potoroos in the wet forest of the Otways. We had to completely redesign the project because we caught precisely 0 potoroos. But down here, they're all over the place. And why is that? Well, one thing that leaps to mind is that if you get down at potoroo height, some of this country is incredibly thick. You're really having to elbow your way through, and that's potentially providing them with a lot of shelter. Which leads us to wonder, well, when we conduct burns in this country and it changes to look like that, how do they fare? I've been tromping around in the Otways since 2012 when I started my PhD looking at fox and feral cat responses to fire, and building on a body of work that other people have been doing. We sort of came up with this theory that perhaps when you've got dense understory vegetation, you can have coexistence between the predators, the introduced predators and the native prey, because not that many predators are there and their hunting success rates are lower, so each individual fox can't catch as many potoroos, and so they kind of manage to hang on. And then when you remove a lot of the understory vegetation in the short term, you get foxes and cats moving into these recently burned areas. You get them eating more medium-sized native mammals because potentially they're more available. And so that may lead, and this was a big question, does it impact the ongoing persistence of native mammals in this landscape and their survival rates and the resilience of the population? This work, to zoom in, as I said, was in the Carlisle Heath, and it began back in 2021 trying to address some of these questions when Mark started his PhD and did some fabulous work where he was GPS collaring the potoroos. These, importantly, are very small burns on the scale of prescribed burns that happen across Victoria. We're talking like 10 hectares, 36 hectares, not thousands. So he trapped in these little blocks. He was fitting the potoroos with GPS collars to understand whether or not they were surviving the burn events. Distressingly, he found that when the burns were happening as normal, here's that picture that Jack already had, 60 to 100% of the potoroos were dying within 4 or 5 weeks of the fire. We're like, this doesn't sound good. This is a valuable stronghold for this species. we've got burns happening, we've got very high mortality rates. But in the terms of big picture species management, the death of one individual doesn't necessarily matter if the population can cope and respond. So we're like, okay, what's actually happening? If you're taking out a lot of individuals with this burn event, what's happening to the population afterwards? So Mark had done a bit of trapping because he needed to put the collars on and then trap again to get the collars off. And so this is where Steph comes into the story. We designed, as an add-on to the Wild Otways project, a spin-off really, we decided to get Steph out there to trap these blocks again 12 months post-fire and 2 years post-fire to identify the density of potoroos. Because if you trap individuals, you put little microchips in them, which Mark had also done as well, and then you trap and trap and trap again, you can actually estimate the density of your population because you get captures and recaptures and you can compare them. So Steph has worked incredibly hard. She's an amazing individual. So she had a lot of traps. She put out 40-odd traps in the burn block, trapped for up to 8 nights, and she's done this 2 years over. She had some interesting experiences with flat tyres and learning you should not trust fleet management services to keep the spare tyre inflated, but luckily Mark came to the rescue, and she met a lot of potoroos, which was really awesome. So in 2022, she did something like 1,500 trap nights, caught 250 odd captures of potoroos with 76 individuals. We thought this was pretty awesome. We went back to the ethics committee and said, do you mind if we have approval to capture a few more the next year, because we think this might be going really well? And lo and behold, 2023 blew that out of the water. So she had something like 488 captures of 114 potoroos. Very preliminary, she hasn't got to doing the density estimates yet, but if we simply look at the rates per 100 trap nights, we can see we've got the control block, which is where no burning happened. That, slightly confusingly, is in red on that graph there. The green and the blue are the 2 different blocks where the burns happened in 2021. And this data shows the number of captures 12 months post-fire and then, you can probably see my cursor. No, you can't. And then 24 months post-fire. So first of all, there was a lot of captures in these burn blocks. And CH4, the smaller burn block, was a bit lower, but CH6 was comparable to the block that hadn't been burnt at all. And then we saw a big increase in 2023, and again at a comparable rate across those blocks. She was trapping in the unburnt vegetation around these little burns as well, and we need to disentangle that from the data. But when we look at the number of individuals, again, fairly similar. So the number of individuals per trap, 100 traps, was higher in the CH6, one of the burn blocks, than it was in the unburnt control, although we did see a slightly steeper increase. So at a very early level, we need to get in and pull this data apart some more. We're seeing really good resilience of the potoroo populations to fire as at a population level, not at that individual level. I have just been kicking this data a little bit to see if I had something else interesting to talk to you about. So I started looking at the distribution of weights of the potoroos. So this is from very light potoroos on the left to heavy on the right for females and males. All the females with pouch young weighed at least 600 odd grams, generally upwards of that. And interestingly, in the control block, about a quarter of quite a lot of the potoroos weighed less than that. And about a quarter of them weighed less than 450 grams. So presumably these are quite young individuals. In CH6, about 10% of them weighed less than 450 grams. And in CH4, none of them weighed less than that. So I don't quite know what's going on there, but perhaps it suggests that there's differences in the population structure. Perhaps in the burn blocks, we actually have older individuals moving in and recolonising, whereas the breeding's happening in the unburnt block. And we have genetic samples from all these individuals. We haven't got the data back yet, but that will help us understand their relatedness and try to understand what's happening in recovery from the fire events. Are we losing individuals and then they're coming back in? Because remember, these are very small burn blocks. So what's next? We also have pre-fire trapping data that Mark collected, so we need to understand how similarly these blocks were to each other before they were burned and immediately after fire. And then Steph is going to get crash course in R and density estimation in the next couple of months before her thesis is due. And so she'll be able to actually tell you how many potoroos we have per square kilometre. And that's a really useful piece of information in terms of understanding building population models, building predator-prey interaction models, and understanding the viability of these populations going forwards. Because this is really key to feeding through into fire management planning in the future and integrated predator management as well. Because the individuals are chipped, we can look at how well they're surviving from year to year. So Steph caught one potoroo, Sunny, which Mark trapped back in 2020 or possibly earlier, 2020. So we're starting to get an idea of the lifespan of these individuals as well. And we may go back there in a couple more years' time to understand more about the population turnover. And as I mentioned, we're going to get genetic analysis, which will tell us about their relatedness. Just to emphasise again how special the Carlisle is, Steph, in the process of putting out all these cages for potoroos, also caught southern brown bandicoots, bush rats, swamp rats, relatively low numbers compared to the wet forest just down the road, and swamp andochinus, which was quite special. So in terms of outcomes, as I said, it is extremely early days yet, but we can see that potoroos are abundant in these very small burn blocks 12 to 24 months post-fire in a landscape where there isn't ongoing predator control. There are potentially some differences in population structure in these burnt areas, and that's something we really need to look into further. But it's important to keep in mind the set of conditions that this has taken place under. So they are very small burn blocks. It's been good years in terms of rainfall, and the burns have been surrounded by high quality habitat where there's a lot of other potoroos in unburnt land, potentially to move back in. Just sort of a bigger picture, we've got another PhD student, Vishnu Ramachandran Menon, who's been using camera surveys pre and post fire right across bigger burnt blocks in the Otways and Glenelg to try and understand whether landscape scale baiting affects the persistence of things like, or the responses of things like potoroos and bandicoots to fire. And distressingly, he's been finding very noticeable drops in potoroo occupancy post-fire and low rates of occupancy, not a rapid rebound in this broader context. So we're putting together a jigsaw puzzle, and I think we've got nearly all the edge pieces yet now, but there's quite a few bits in the middle, and we're trying to understand a bigger theory because it is important to be able to extrapolate our findings across. We can't go out and trap in every single burn block, but we are learning a lot along the way. Thank you.